Welcome to BeeGraphy. In this 8th tutorial, we are going to see how we can create a dynamic facade using parametric designing. In this case, we can see that there are diamond panels on the skin of the building, and there is also a black framework in which these panels are rotating. And also they are responding to the sun, the direction of the sun. So it is moving such that it always faces the sun, thus reducing direct sunlight. The main aim of this tutorial is firstly to show you these different paneling components, and then how you can control the geometry and control these panels using parametric designing. And also the finer nuances such as giving thickness to these pipes, this framework, how do you connect it to the building, how much the gap should be, and so on. So without further ado, let us begin. So I have my canvas on the left side and the 3D model on the right side. First of all, let's create the basic building. So we've got a box, right? So this will represent our building, and then on one of the faces we are going to create the facade. How to do that, how to extract a face from this 3D object is deconstruct solid, right? Because in the first node, the box node, the output is just a box, a 3D box. So if I put it here in deconstruct solid, we will get all these surfaces, the 6 surfaces, 8 corner points, and all these lines. Also, let me show you a shortcut of creating nodes and connecting these nodes. So instead of creating a panel tool and then connecting it, if you want to check what is coming out, what you can do is simply take the wire, just like you connect wires, but take it and then drop it in mid-air, and then type in whatever you want. Like if you want deconstruct solid, it won't work, but you get the point, right? So you can take this, and then if you want to interpolate all these points, you can do this. So this is really helpful. All right, so we've got the solid, and then we've got all its surfaces. We are going to select one of the surface. To do that, we are going to do list item, right? Just type in item, and the first one is list item. And what list item does is, if you are giving it a list of items, in this case there are the 6 surfaces, you can select which surface you want by putting a number in index. Let me demonstrate. Let's take a range input, put it in index, and hide everything else, right? So this is the 4th surface. Sorry, the 5th surface, because the numbering starts from 0. This is the 0th surface of my box. And then when I go to 1, it is just in front of it. So 1 is what we want. You see, this one is the surface that we want. So I've extracted the surface. Now let me hide this so that we can just look at the building and the surface of the building. Now what we are going to do is subdivide this surface into several panels. So when you type in panel, you can see several types of panel: hexagonal, diamond, triangle panel, C panel A. So just experiment with different panels on your own. But for now, we are going to use diamond panel. This is a hexagonal panel and diamond panel. Most of the things are same when we are looking into it. You see that all these panel components have got U ISO, V ISO, and a surface. These are the inputs that it requires. U ISO, V ISO is the number of subdivisions in the vertical and horizontal axis of the surface. So I'll demonstrate by putting in some numbers, and you'll be able to see what happens. Right, so UISO in this case, it is changing the number of rows. If you increase it, there will be more number of subdivisions, and for this one it will be vertical column divisions. So I want them to look more like diamonds, so let's do it like this, 6 and 10. Now why I chose diamond? Because it is slightly more complicated and there are more types of outputs coming out of it, and this will help me demonstrate you how to remove things and select only that geometry that you like. In this case, we have got, wait, I'll do this. So we've got these diamonds in the middle, corner triangles, these right angle triangles on all the corners, and then there are these edges that are here. So for our panels, we are only going to select the diamonds that are in the middle. All right, so this was the first step. We select only the diamonds. And then we are going to create the surfaces on these diamonds, and then we are going to rotate it. Why I'm not taking the surfaces directly is because in surfaces, all of these triangles, diamonds, isosceles triangles, right triangles, everything is in one list. It is not segregated. You can see it here. There is just one list of 39 items that includes all of them, and I don't know which of these surfaces represent a diamond or a right angle triangle or the isosceles triangle on the edges. But very conveniently here they have given us only the diamonds. Also they are in curves, so these are not surfaces. So we need to connect this diamond curves to surface. So there is a node called curve to surface. We are going to connect all these diamonds and we will get these surfaces. And there are 23 diamonds in total. All right, let me rotate it. Rotate it so that all of them can rotate around their center. Now there are 23 geometries that are going into rotate node. The angle, let's set up that degree to radians, and then the center will be the center of all these points. Right now the center is origin, so the entire system of diamonds are rotated around origin by 45 degrees. I want each of them to rotate around their own center. We've done this before. I'm going to do centroid. The geometries are all these 23 geometries, and instantly we can see their centroids have been selected. As soon as I do this, you can see that they have been rotated. And if I hide everything else, you can see that that geometry, all these diamonds are rotating. Amazing. Okay, so this is 0 degree, and then this is 90. So one more thing to note is if you wanted to rotate on the left side, so from top it would be clockwise, we need negative angles, minus 90 to plus 90. So we can simply change this min to minus 90 and the max to 90. Yeah. Wait a second. Yeah, perfect. It is going from minus 90 then 0 is flat, and then 90 is on the right side. Okay, so we have rotated our panels. Now there are two things to do. One is to bring all these panels a bit further away from the building so that when it rotates it does not coincide with the surface of the building. And then secondly, there will be the framework that we are going to create. So let's bring all these panels up. Now there are several ways to do it. You can move this geometry in front of you, or you can go back and where is our surface? This. You can move this entire surface in front of you and then compute all these things. I think that would be a good option. So let me offset surface. And the reason I'm doing this, if you remember even the previous one, if I move this geometry, that will also work. But what's happening is these diamond panels are being created, curve to surface, then they are being rotated. So now there are two sets of diamond panels. And then when I move it, there will become three sets of diamond panels. So to reduce at least one set of diamond panels, I'm going to introduce this offset surface right at the very beginning. Now this surface is what will go into diamond panels, and everything has now come in front of it. And this surface will be imaginary, so I can hide that. Right, now let's see. Perfect. Now let's introduce a framework. If you remember, we've got diamonds that are polylines. Let me show you. These diamonds are closed planar curves. All of them are curves with 4 sides each. So there are 23 diamonds, and then 23 into 4 lines are inside this. If I do pipe, what pipe does is it takes a curve and then introduces a pipe on it, a cylindrical pipe. And let me reduce the radius first, otherwise it will be massive. Let's take 0.1, put it here. Nice. So we've got our pipes with 0.1 units radius, and the issue here is you can see this overlaps happening. That is because this is a pipe for this diamond, first diamond, but there is another pipe that is for this diamond, which is coinciding with the first panel's pipe. So we need to remove all these duplicate lines that are coinciding with other lines, and thus there are double pipes being generated. And the reason this is important is not only because of this rendering issue, but also computation. I'll explain you what I mean by that. First of all, I'm going to explode the curve. All right. So when I explode the curve, I am getting each individual line of all these diamond panels. So now there are 23 branches. Each branch has got 4 lines. Each branch represents a diamond curve. All right. And that's why now this is dotted. So the curves have been, the data is now branched. If I flatten it, all the branches will disappear and we will get a single list with 92 lines. Okay. Now the issue is there are 4 lines here and there are 4 lines here, but all these lines are doubled. So we need to remove that. And if this was like 100 or 1,000 1,000 panel system, that would be a lot of extra geometries that the computer is working with. So there is a node called cull curves. Cull means removing or deleting. And if I put this here, you can see that the number of lines have reduced to just 60. So 32 lines have been removed. See, this was 90, and then when we removed the the duplicate curves, it has now become only 60. Now we put this into our pipe system. And instantly you will be able to see that there is no rendering issue now. You see, there was rendering issue because two colors were coinciding, two pipes were coinciding with each other. All right, so this was really nice. So in this case, I explained how we can explode curves, a polyline, then how that data structure, how the data is structured inside it, and then why did I flatten it, and then I remove the duplicates. And flattening was really important because if I directly put this branched data structure into cull curves, it won't remove it. You see the rendering issue is there. I mean, I can see it in my system. You can see their grain-like structure because it is coinciding. And even if you can't see it, I can prove it by flattening the output and connecting it to my panel. You see 92 items. Even though it is going through cull curves, it is not removing it. And this is really important to understand because when it is checking for duplicate curves, it's not checking for everything. It is only checking for each branch. Each branch has got 4 lines. Each diamond has got 4 lines. And it is just checking for these 4 lines, and then it is moving on to the second branch, and then it is checking for these 4 lines. It is not inter-checking amongst these branches, and that is why it is not removing it. That's why we need to flatten it first, and then we cull the curves. All right, so we've got our pipes. Another issue that's happening is you can see that our panels are intersecting with the pipes. We need to reduce the panel size. Very easy. We will, again, we can do it here, or we can do it right at the beginning of the script. So I'm going to do it here. Let me move everything a bit to the right because I'm introducing a short script for reducing the diamond size. I'm going to offset it. Since the diamonds here are coming out as curves, as a polyline, I'm going to use offset curve. And you can see that it's first of all it's offsetting by 2 units, which is massive. Even if it is 1 unit, it's huge. And also they're being curved. That is because we've talked about this. We need to change the offset type to intersection with a capital I. Remember that. Right now it was an arc, so that's why it was curved. And then the third one is tangent, which also gives you sharp edges. All right, and the distance will be the distance will actually be equal to the radius of these pipes, right? So this is the pipe. The entire diameter is this big, and the diamond is going through the middle. So we just need to remove that part. So we are going to offset only the radius of the pipe. The radius of the pipe is here. So let me create 0.1 range input, and this range input will go into pipe radius as well as the offset. And I'm doing this for convenience. so that when I change the radius of the pipe, automatically the diamond's offset will also change. All right, so now it is perfectly aligned with the edge of the pipes. Now, what we're going to do is use this output as our diamond panel geometry script. So no, I can't do that because it's also taking this. All right, I have an idea. So I'm going to do Control Shift and do this, and then connect this with curve. Um, okay. So the offset that's happening is not inside, it is going outside. And I'll demonstrate how I came to know about that. Let me increase the max to 0.3. Oops. And you can see it is going out. Yeah, so that's small. Or even if you turn on the diamond panel, you'd be able to see it. Anyways, the distance is positive, and that's why the offset is happening outwards, and the diamond is going beyond the surface. It's intersecting with each other. Simple fix. We need to introduce a negative converting node that will convert the 0.1 to minus 0.1 and put it into the distance. So even if you type negative, you will see this opposite node come up, which has written n and minus n on it. So if I connect it here, the output will be minus 0.1, and I'll put this into my distance. Awesome. All right. I just realized a problem. This exploding, then flattening, and then the curl curves thing should happen here before offsetting it, because once I offset it, the lines are no longer coinciding. So we can see that the output is again 92. If I had my diamonds here, then it is 60. So the pipes that are to be created should be connected directly to the diamond panels, whereas these diamond panels, they should be connected to the offsetted diamonds. So I'm glad that happened. Awesome. So let's just check once if it is working as intended. Perfect. You can see that the diamonds are also reducing as the pipe's radius is increasing. You see these red lines? That's my diamond. So this is perfectly working now. Awesome. So we've got the framework, and we can see that the panels are now rotating without intersecting either the building or the pipes. That is the framework. Awesome. So in next part, um, we will we will connect this framework with the building, as well as we are going to connect the distance of the building with the width of our diamond panels. We are also going to see the number of floors, how to subdivide it according to the number of floors, and then we will either introduce a tractor point, or we can introduce the sun path and see what dynamic shapes and forms these panels create for you. So see you in the next tutorial.